So, welcome to the factor analysis webinar. It's very much an introductory webinar. I think a few of you may be missing the very bottom of the screen. Hopefully that will not be used during the main part of the webinar anyway. I've moved a few of the bits around. So, what are we going to cover today? The first thing is we're going to look at some definitions and history of factor analysis. Then we're going to take a worked example and work it through. With something like factor analysis, I find it's a lot easier to take some specific data and follow that through and talk about the various decisions that we make when we're using factor analysis. Then I'm going to do some tips for using better factor analysis, and then we'll do some Q&A at the end of that. Okay, so factor analysis. A couple of kind of scary phrases. I'll put these up and then we'll come back to them and unpack them, and I think you'll feel pretty comfortable with them by the end of the process. Factor analysis is there to reduce the dimensionality of a space. So I'm going to explain what that means, and it does that by finding latent factors, and I'm going to explain what that means. So we're all pretty familiar with some reductions in dimensionality. On the left-hand side of the screen, we've got a globe. A globe's fine, but a map is much more practical. So we take a three-dimensional object like a globe and we produce a two-dimensional object. We've reduced the dimensionality. If we've got a questionnaire with 25 attributes on it, that's a 25-dimensional space. It's a complicated one because those dimensions are correlated with each other, unlike the dimensions we're used to. When we talk about 3D, as in a globe, those dimensions are all at right angles to each other, and we call that orthogonal when we're talking about statistics and marketing sciences. So reduction in dimensionality is just like going from a globe to a map. When we do that, of course, we distort the picture. There isn't any method of going from a true three-dimensional picture to a true two-dimensional picture. In particular, what happens when you go from a globe to a map, the way we traditionally do it, is you make some countries like Greenland, and in particular United Kingdom, much larger, and it tends to compress countries around the equator. So when we reduce the number of dimensions, we do lose information, and we're going to see that pattern crop up again. I'm going to go back in history, back to those wonderful days of the polymaths in the early part of the 20th century. Charles Spearman, a psychologist, but also a prominent statistician, a developer of statistical techniques. You might remember him in terms of Spearman's rank correlation coefficient. Well, one of the projects he was involved in is that he took lots of measurements of people on different types of tests. And he took all those sorts of tests where people who did well on them were judged to be intelligent. So they might be maths tests, they might be reasoning tests, they might be logic tests. And he looked at these tests, and after working on the results and doing some statistical analyses, he hypothesized that there was an unmeasurable something, a G he called it, general intelligence, which tended to cause a high score. So if you got a high score on maths, it tended to be because you had a high G, general intelligence, and a high aptitude and training or knowledge of maths. If you did well on logic puzzles, it's because you had a high G, general intelligence, and a high something suited for logic puzzles. So what he did was he used factor analysis on people's scores on lots of different tests and identified the contribution and the size of this factor G. Now, it's been criticized since then because it was culturally situated. It depended on levels of education and assumptions about what intelligence was. But it's moved on since then, and we call that latent factor IQ. And we still dispute what it is, but everybody agrees you cannot measure it directly. So if we talk about real customer satisfaction, we can't measure it directly. We measure other things to try to find what is the latent factor. Advocacy. Even really liking a brand. We know that all we can do with our measurements in surveys is find a few ratings, but we're not getting to the real underlying truth. So the latent factor drives the observable data. The observable data doesn't create the latent factor. The latent factor creates the observable data. And in that way, you can see that factor analysis links very closely to a technique which we'll be covering in a webinar next year called structural equation modeling, which is all about latent factors. So latent and manifest. Your scores on a verbal reasoning test, a maths test, a spatial puzzle are observable. So those are manifest variables. We can see them, we can measure them. Your IQ affects your scores on those tests and is hypothesized latent variable. It can't be measured directly. So all the time we're working, when we're doing market research studies, between things we can measure but which are actually caused by underlying latent factors and structures that we have to try to identify through mathematical techniques. And the preeminent one of those for doing it is factor analysis. Another reason that we're very keen, and those of you who saw the webinar last week on cluster analysis will recognize the next three charts. Another reason we're very keen in market research on factor analysis is it deals with collinearity. Here's a study, and maybe I chose to have 5 attributes on it, and unfortunately 4 of them, quick, fast, speedy and slow, which sound a little bit like the 7 dwarfs I suppose, are all incredibly correlated. If we simply took that data for those 5 attributes, we'd only be measuring 2 things, and what's more, we wouldn't really be measuring happy because so much of the data would relate to that first intercorrelated aspect. What we think is that underneath that there are probably 2 factors, one which is pretty much to do with go faster, go slower, and one which is somewhere over in the happy zone. Now that might result in us picking 2 of those attributes to use them, or it might mean that we're looking for the underlying structure. But both ways, we want methods of measuring what that underlying structure is. So here's an example using SPSS. I've taken some data from Gapminder. If you're not familiar with it, I really recommend you go to Gapminder and visit it. It's from Hans Rosling, and it's some of the best visualization of data. So I've taken data from 140 different countries around the world, because a lot of market research data isn't terribly available to be used in public. So I've taken this data from 140 countries around the world, and I've taken 8 fairly arbitrary characteristics. So how many, in the first column, 4 deaths per 100,000. How many people die in each of those countries out of 100,000 population from falling? What is the life expectancy at birth in each of those countries? How many cell phones are there per 100 people? So in Afghanistan in 2005, which is when this data relates to, 4 cell phones or mobile phones per 100 people in the population. In Albania, there were nearly 50 mobile phones. In Argentina, over 50 mobile phones per 100 people in the country. Next column, fire deaths per 100,000. How many people died in fires per 100,000 population? Next column, how many people died of tuberculosis? Next column, what is the alcohol consumption in litres? In Afghanistan is about 0, Argentina up at about 10 litres. What percentage of the land is in agricultural use? So in Afghanistan, a lot of the land is in agricultural use. We see that in Algeria it's somewhat lower. And what was the age, the median age at first marriage of females? So in Afghanistan, the median age is fairly low at 17.8. In Algeria, it's pretty high at 29.6. So this is the data that we're going to put into SPSS and run it through factor analysis. When we do that, it's pretty straightforward. We go to Analyze, and it comes up with dimension reduction. Remember I was saying that that is essentially what factor analysis is, and we click on Factor. And there are various options that you can choose in there. Well, I'll show you some of these screens, but you can say, please show me the correlation matrix, and that's well worth doing, I feel. And here's a correlation matrix. It shows the 8 attributes against the 8 attributes, and I've highlighted in colors the cells where there is an interesting correlation. So if we take life expectancy, we see that there's a positive correlation between it and cell phones. People who have cell phones are more likely to have a longer life expectancy. People with a longer life expectancy are more likely to have cell phones by country. Countries with a greater number of TB deaths or a greater number of deaths by fire are less likely to have long life expectancies. There's a negative correlation between the two. If we take that cell phones row next, we can see the life expectancy correlation, which we've already looked at, move a bit further along, and there is a positive correlation between alcohol consumption in litres and cell phones. and a positive correlation between age at first marriage and cell phones. And there are quite a few other correlations in the matrix. So we can see this data doesn't really represent 8 orthogonal attributes. There are interrelationships. We want to reduce the number of dimensions. We also want to see if there are some underlying structures that help explain the data. One of the first questions you get when you run factor analysis is you've got to decide how many factors they're going to be. And unlike a technique like cluster analysis, there is a lot of guidance. But some of that guidance is a little bit confusing because when you run the software, it will report back that you put in 8 attributes, so there are potentially 8 factors. For every one of those factors, it will calculate what is called the eigenvalue, and I'll talk about that in a moment. And it will tell you what percentage of the variance is accounted for by that factor. And if you use all the factors up until that point, what is the cumulative amount of variation that's been accounted for. So the first factor in this factor solution has got an eigenvalue of 3.5, and it on its own would account for 43% of all the variance. So all the information that would contain on 140 countries across 8 attributes can actually be represented by one underlying concept, 43% of it. If we add in a second factor, well, that second factor would have an eigenvalue of 1.4, and I'm coming back to what the eigenvalues are in a moment. And it adds another 17% of variance. So if we just use 2 attributes, 2 factors, we'd be accounting for just under 61% of all the information in the original data. If we go to 3, we'd be accounting for just over 75% of all the information. Now 3 is the level that we would traditionally use with this data because what psychometricians and statisticians have found in the past is that generally eigenvalues of greater than 1 are the ones you want to use. And if we look down that first column, the eigenvalues get 3.5, 1.4, 1.2. So the first 3 have all got eigenvalues greater than 1. The fourth one has an eigenvalue that's less than 1. Well, what exactly are the eigenvalues? If you look at the bottom where there's a row called sum, you'll see there's 8, and that's for a reason. When we started off with our raw correlation matrix, we had 8 attributes by 8 attributes. And you can think of that as a matrix where there's a multiplier of every row has got a weight of 1. And what the factor analysis software is doing is it's shuffling them around so we can end up with as much information as possible on the first row, and then as much information as we can on the second row. So instead of being a 1 in the first row, it went up to 3.5 because we managed to shuffle the data around and push that information into there. And then we pushed information to the second one. So by the time we get to the fourth row, at 0.7, that factor is adding less than a single attribute would have done before we started the process. And that's why it was picked as an arbitrary level to say, okay, an attribute without going through the modification process was worth 1. So any factor that is worth less than 1, we're not going to use. However, that is an arbitrary level. If there are perfectly constructed underlying factors, it is quite realistic to do that, but sometimes you want to override that decision. Remember, it's your choice whether to override that decision. The standard default is to say, I only will use eigenvalues greater than 1. Now those eigenvalues, turns out their relationship to things like variance is pretty straightforward. So we started off with all the numbers being equal to 1. We shuffled them around and we said the first factor was worth 3.5. There are 8 of them. 3.5 divided by 8 gives us that 43.2. And in effect, the eigenvalues will make a matrix from matrix algebra that if you multiply back by the new factor solution, you would get back to the original position. And there are a set of weightings that are used in that way. As well as looking at eigenvalues that are greater than 1 to decide on the number of factors, always look at the Scree plot. A Scree plot is a printout of how much improvement there has been for each step. It's supposed to look a bit like a mountainside. A Scree is loose shale on the side of a mountain. And what we see there is that the 4 components, or the 4-factor solution, has got that quite low eigenvalue. And as we move along, the next few eigenvalues are all very similar. So again, we'd feel reasonably comfortable in taking a 3-factor solution with this data. We would bear in mind that we've accounted for 75% of the information and we have lost 25%. So while 75% is pretty good, 1 in 4 of all the information in the original matrix has been lost. So what are those factors? Well, this is what you get from the raw factors, and normally when people run SPSS you'll see 3 decimal places. I hate that. You really can't interpret it. You end up looking at the wrong part of the number, so I would always suggest reduce them down to 1 decimal place. And these are loadings, so they are like correlations with factors. They're like the cosine of the angle between the attribute and the factor, so they're going to range from -1 to +1. And what we see is that factor 1, which accounts for 43% of all the variation, has taken almost all the big numbers. It is heavily correlated with life expectancy and cell phones. It is negatively correlated with fire deaths and TB deaths. It's positively correlated with first marriage. It's positively correlated with alcohol consumption. And that's where a big chunk of the information is. The second factor is positively correlated with alcohol consumption and positively correlated with falls. And that looks to be a fairly persistent relationship. Bear that one in mind because it's probably worth investigating some more later on. The third factor is positively correlated with falls and negatively correlated with land in agriculture. But the problem with that solution is that factor 2 and factor 3 don't have any really strong numbers. Remember, a 0.7 correlation means that 50% of the variance is in common. If you square the correlation or square the loading, you've talked about how much is in common. So there's nothing that's strongly distinctive about factor 2, nothing that's strongly distinctive about factor 3. So we'd like to look for better solutions. Just before we do that, you can force the data and say, I only want 2 factors. If you do that, you can ask the factor analysis program to give you a plot, and that's what I've done here. And what you will see is that it's reduced the data from, if you were a Western free living, fun living sort of person, you'd say, well, this sort of runs from good to bad, like a lot of market research data does. So over on the left-hand side, we've got TB deaths, fire deaths, followed by fall deaths. Agriculture, whilst it's really nice to watch, most of us wouldn't really want to work too heavily in agriculture. And then on the right-hand side, we have plenty of alcohol consumption, we're marrying late, we're using cell phones, and our life expectancy is good. So that's the dominant characteristic that runs through that 2-dimensional space. Here's the screen in SPSS that allows us to control all of that. So I would always say, yeah, I want to show me the unrotated factor solution. We're going to talk about rotating factor solutions in a moment. Yeah, always pick that show me the Scree plot. Extract based on eigenvalues greater than 1. Remember, you can change that. So sometimes you might want to say, show me a bit further. Normally when you want to look a bit further, what you do is click on the second radio button, and I might on this data say, no, show me the 4-factor solution. I think it might just be interesting. Equally, when I wanted to produce that component plot, I clicked on the second button here and said, show me the 2-factor solution, and then the component plot was quite straightforward. The component plot of a 3-factor solution is printed in 2 dimensions and is fairly unintelligible. Now, one of the things about the data is that it doesn't care what meaning you as a user are going to put on that data. And my analogy here is that if we had put all the data in about the globe and it had come up with a solution, it might change north down to be on the side, and we might be really interested in understanding a research problem about the Americas, and it might happen to show us Africa and Europe and a tiny bit of Asia. So we can rotate that globe, we can rotate it left, and then we can rotate it round in order to get another picture. We have not changed the data. We have not changed what is involved in that process. It's still the same globe, it's still got the same countries, but we've rotated it to make it more meaningful to us. And that's something we do with factor analysis all the time. We should do. There are some purists that say you shouldn't rotate the data. That is because they don't want you to interpret the information. Market researchers absolutely do want to interpret the information. That's why we've run the study. But you've got to recognize that that process is qualitative. Everything we've done so far fits a positivist epistemology. It is about definitive numbers, going out trying to measure something we think is really there. Different practitioners will come back with the same results. However, in choosing which rotation to use, different practitioners will not come back with the same results because you are bringing to bear what you already know about the market, what you believe your client needs to know, what you are looking for in your analysis path. There are 3 types of rotation that I would recommend, and I'm going to show you those in a moment, but this is the page where you would pick it, and then on this page you can see that there are more than 3 types. I would strongly advise not using the 2 with the big crosses, the Oblomin and the Promax, because they produce results which are not orthogonal. Now, some people don't worry about that. They say, well, I'm going to treat it as a much more qualitative process. I think if you've gone to the bother of running factor analysis to produce orthogonal factors, stick with them. Use the 3 that maintain that are just like changing the globe around and rotating the globe. If you use the direct or the Promax, what you are effectively doing is changing a football, a soccer ball, a round globe into something more like an American football. You're changing the fundamental shape of the data. So we've got 3 possibilities. And what I would normally do is I'd normally run them all. So on the left-hand side of the page, we have the raw data that we discussed, and on the right-hand side we've got Varimax rotation. Now, what's happened when we compare the 2? If we look at factor 1, we can see on the right-hand side of the page in Varimax, it is not quite as distinctive. It doesn't have any 0.9s anymore, and it only has 4 that are highlighted compared with 6. So it's no longer hogging all the information, and it's become perhaps a little bit more narrow in its definition, which is good for us in terms of trying to use it and explain it. It's saying it's associated with cell phones, it's associated with alcohol consumption, it's associated with higher age at first marriage, and it's associated with higher life expectancy. If we move on to the second factor, we now have a much clearer picture. It's associated with living in a country where a large proportion of the land is used for agriculture. It's associated with higher levels of deaths from tuberculosis and low levels of life expectancy, so subsistence agriculture. If we go to the third column, what we've got now is quite interesting in that it's hardly associated at all with the first 6 attributes and really strongly associated with deaths by falling and deaths by fire, accidents in dangerous countries. So all of a sudden we're starting to get a bit more of a picture, and I like the Varimax compared with the raw. One of you could be looking at that and saying, well, actually, no, I can see the sense in the raw and I would prefer to raw. That's why we're now into a qualitative stage of the analysis. So we've got Varimax, we'll keep that. Now we'll compare that with the Quartimax. Quartimax kind of goes back, in my mind, a bit towards the raw data. It's loading quite heavily on the first factor. It's saying cell phones and alcohol consumption, age at first marriage, life expectancy, and negative on fire per deaths by fire. So it's a little bit less clear to my mind in terms of that first factor. The second factor, it has moved a little bit more towards just being land in agriculture and TB deaths, and it's lost a bit of its emphasis on life expectancy. So it's slightly broadened the definition, I think, of what sort of agricultural countries are involved in that. We go to the third one and we see that it's still fire deaths and fall deaths. So there's not a massive difference between Quartimax and Varimax, but I prefer the Varimax. I think that the 3 factors are sharper. I think that I can see more clearly what they mean. Somebody else may well look at the Quartimax and say, no, that's the one that I would go for. Finally, we run for equimax, which is pretty much a combination of the Varimax and the Quartimax, and combines the 2 strengths together. And frankly, they are incredibly similar. If we'd shown these to 3 decimal places, people would tend to talk about the differences they could see. But those differences are what I would call a spurious level of accuracy. There really isn't much accuracy beyond the first decimal place. So look at the numbers at that level and you can see they're overwhelmingly similar. I have a slight preference for the Varimax over the Equimax. I wouldn't worry over it, but I would probably use the Varimax because I do more often. I'm a creature of habit in that sense. So now I've taken a rotation of the data, which I think makes it easier and more meaningful to use that information. Now we can either just take that information away, or we can do something called creating factor scores. When we run a factor scores in SPSS, it saves them as new variables. So it replaces that original data we collected with factors, which are 3 new attributes in this case, F1, F2, F3, and we can use those in crosstabs, we can use them in analysis, we can recode them, and we can use them in a variety of ways. And what I've shown here is some thinking based on taking that data and exporting it into Excel and then sorting it using filters in Excel. So on the very right hand side of the page there is factor 1, and at the moment I'm still calling it factor 1. I advise not naming the factors too early. And on the right hand side we can see the strongest score on factor 1 is Hungary. It scores 2.5, Ireland 2.1. So we've got Hungary, Ireland, UK, Lithuania. How do these relate to the real data? Well, once we look at the real data is that those are countries with good life expectancy ranging from 72 to 79, high levels of cell phone usage. In Lithuania there are 127 mobile phones for every 100 people in the country. Alcohol consumption really quite high compared with other countries, particularly Hungary up there at 16 litres. Age at first marriage much higher than for other countries, in the UK 30, Ireland 31. So those are the things that are driving that high factor score. At first I thought it was slightly, when I first saw the data I thought, oh, I'll call this group Western. And then I noticed that the USA was quite a long way down the table, just scores 0.7, so it's positive on this factor but not that strongly. So I looked at the data and, well, great life expectancy 78, cell phones only 71 per 100 people, so really a different category. Alcohol consumption really quite a lot lower, and slightly low on age of first marriage. So I thought to myself, would it be meaningful to call a group Western when it would exclude the country that most people around the world would think of as the West? No, it wouldn't. Maybe we need to think more along the lines of fast living or decadent or hip or something, rather than just Western. At the other end of the tail, and it's very often important to look at the bottom end to get a picture about what a factor is doing, we can see that we've got Vanuatu, Mali, Solomon Islands and Niger. So relatively low life expectancies, incredibly low cell phone usage, very low alcohol consumption, and lower age at first marriage. So we can see what that factor is doing, and we can start to think about naming it, but we've rejected Western as a naming for that cluster. We move on to the second factor. Again, I've ranked them all by their score on factor 2. So Swaziland scores very highly at 3.7, South Africa, Burundi, Nigeria, Rwanda, all African states. At the bottom end of the table, we've got relatively small countries, Malta, Kuwait, Oman, United Arab Emirates and Singapore. And we can see how those score. So the life expectancies in those countries at the top, the African countries, really quite low. TB deaths per 100,000, really very high. Look at how low the numbers are for the countries at the bottom. Percentage of land in agricultural use tends to be very high. We drop to the bottom, and there's only Malta that moves off insignificant as a valuation within that. So this would start to suggest rural poor. You know, this is not rich green agriculture as you might know it in the Netherlands or somewhere like that, or Denmark. This is agriculture associated with poverty, associated with subsistence and low life expectancy. So finally that takes us to the third factor, and when I saw that the third factor was made about fall deaths and fire deaths, I thought to myself, oh, maybe I'm going to call this one dangerous. I then looked at the countries at the bottom. This is 2005 data. Bolivia and Georgia are really quite dangerous countries. They're dangerous for different reasons. They're dangerous, more likely to be shot in terms of sort of civil war, insurgencies, drugs wars and so on. But nevertheless, I couldn't call this one danger. I don't like accident prone because that implies that it's the people. It's unlikely to be the people. It's more likely to be due with the fact that these places are busy, they're being developed, people are living close together in buildings that easily catch fire. One slightly interesting one is that Hungary, which was the highest on factor 1, also is quite high on this factor, and they are high because of their fall deaths but not their fire deaths. And we saw that association in the data when we were looking very early on between high alcohol consumption and higher levels of death by falling. And that might be something we want to break out, because I suspect that this solution, which looks after 75% of the information in the data, is beginning to lose a bit of interesting subtext about a link for some countries between alcohol consumption and deaths by falling. So just some thoughts about naming the factors. The names, just like cluster analysis, the names can become more important than the data, and that is a real problem. So you start off working with the data, you give it a name, somebody starts drawing pen portraits, making up little caricatures, and those take a life for themselves. So if I'd called that first factor Western, people would start to talk about trying to be more Western, and Western is this, and it might not fit terribly well. So the term IQ has been a term of abuse and a term of praise. Emotional quotient, the Myers-Briggs categories, when we start to think about different measures within brand advocacy and so on, quite often the names become more important than the data. So that's why I would really strongly suggest naming the factors as late as possible in the process, so that you've got a really good understanding of the data and that they give you the best possible representation. What do people use factor analysis for? Well, I could have perhaps started with this slide, but I decided to use it more, to put it in at the end, because I think I can explain better now about why you might use it. The single most important use of factor analysis, I believe, in market research is to remove attributes from a study. A client comes to you and they say, we're getting falling response rates, they don't want to do our 50 attribute study, and you run a factor analysis on it and you say, well, really, you're only asking 3 things at the moment, value, friendly, and cheap. So how about we cut down to 2 attributes that load really heavily on each of those 3 factors. That's 6, and maybe we add in these 4 things which, when we look at the open ends, people keep talking about, but you're not asking them at the moment. So we can use factor analysis to strip back the questionnaire to make it less redundant, less repetitive. We can use it as a first step for regression. Lots of advanced techniques require that the data is orthogonal. It isn't when we collect it. It's got multi-collinearity. It's all correlated together. We might want to use regression to do driver analysis. Which attributes promote advocacy? Which attributes promote customer satisfaction or reusage? To do that, we really want to make those properly shaped attributes. So we'll use the factor analysis and we'll put factor scores into that driver analysis. We might use it as a first step for clustering. As those of you who saw the webinar last week will know, what I would then say is don't put the factor scores in. Take 1 or 2 attributes from each factor and put in those attributes into the clustering analysis. You want a bit of variability, you want a bit of lumpiness in the data, but you don't want to have highly correlated attributes. We can use it for creating factor scores. So we've got a customer satisfaction survey and we've found out that it's to do with quality, cheerful, and frequency. Well, let's report them as either we might just group the attributes together by those characteristics. We might replace those characteristics with their factor scores to make a very reliable measure of how things are moving. We might use it as a method of focusing the reporting. So again, we can either use the factor scores to focus that reporting on 3 or 4 attributes, or we can use individual attributes out that typify those factor scores. So we can make the process of reporting the information, the process of thinking about the marketplace, a lot simpler. If we're trying to think about 20 attributes, we've got a very fuzzy picture. If we can break it down to 4 or 5 factors, we can have a better impression of what is going on. So finally, raised tips. The first one is to avoid missing data. This is the same for most marketing science techniques. If there's missing data, you've got a few choices, none of which are very nice. The first is you delete all the respondents with missing data, and that's clearly just wasted the client's money and the respondent's time. within something like factor analysis, you can miss out bits of the data. So every combination of attributes where one piece of information is missing, you would drop that one and you'd work through and you get some sort of picture. Or what happens is you allocate means, and SPSS makes it really quite easy to fit means in instead of the data. But of course those means are not what people would have said. They will make the data much blander, they will reduce the definition, they will reduce your ability to interpret the information. A similar problem comes from don't knows and not applicables. If there is a don't know in the data, so you've got a scale that runs 1 to 7, then 8 is don't know, clearly you can't code that as an 8, you've got to remove it. So you're either going to make it missing data, or you're going to put some other value in, midpoint in maybe. So instead of the respondent guessing what their feelings are, you're going to guess what the respondent's feelings are, and clearly that's not a great position to be in. Sometimes there isn't much choice because you've got a battery of maybe 20 attributes, and 3 of them are my children really like it, it's good for my husband, my parents quite approve of it or something. If you don't have husbands and children, then you want to tick the not applicable box. That's going to make it difficult to process the data, and I think you've got a couple of main choices then. The first one is run 2 separate factor analyses, one on people for whom those questions do apply and one who don't. Or secondly, and this is probably a bit more practical, remove those 3 questions, run your factor analysis, produce your factors, and then calculate the correlation between the 3 attributes you've removed, for example 3 attributes, with the factor score. So you work out what their loadings onto the factors should be. You don't allow the missing data or the average data to actually create those factor scores. Please remember that the practice of treating eigenvalues greater than 1 as a method of taking the factors is simply experience-led guidance. It's not an absolute rule. Definitely look at the Scree plot before you make a final decision. Yes, do look at rotations, but look at all 3 rotations. Decide which is the best explanation of the data today for your client, for the research problem you have today. Once you've got your scores, then I'm a great believer in creating factor scores, putting those factor scores into your cross-tabulation programs, running lots of analyses, and really getting an understanding of what those factors mean in terms of the data. You've got a lot of knowledge about this marketplace. Make sure that you look at what these factor scores are doing and this latent factor structure is implying before you start naming the factors.